Distinguished guests, ladies and gentlemen, I would like to ask your attention for a very special intermezzo. A very special intermezzo. And without giving away anything of what is about to come, I have one very strong request. Please remain seated. Please.
Well, the idea of the academic year prize is to introduce a broad audience to the science we do at Wageningen University. In our case, it's the science of how animals fly. And well, that's the chance and that we got here, but we thought it was kind of boring in a way just to introduce people to our research. We thought it would be more exciting to make them a participant of our research because we're also very excited about our research. And that's kind of the basic idea of our project, to make the general public a participant of our flight research.
David, this type of research is physics. Many people think about Delft to do this type of research. What does Wageningen do with this type of research?
Well, I think in Wageningen we all care much about the environment, about nature. And what's something that we often forget in the Netherlands is that we have some beautiful nature outdoors, even in our backyards. And what's so special about the high-speed cameras that we're using in this project is that people can watch through the high-speed camera a completely new dynamics of the motion of how animals and plants fly in the Netherlands. So a very typical animal, like a dove or a pigeon, becomes something spectacular.
Can you tell us a little bit more and maybe show us also a little bit more about the results? Because you bought the high-speed cameras, you've made films already together with your students. Can you tell us a little bit more about it?
Yes, so we're with a team of colleagues, assistant professors, PhD students, and MSc students from Wageningen University, and we have 30 high-speed cameras that we will borrow to the general public. We have 800 participants, and besides those 30 cameras, we also have one very special camera, which is the Phantom V710 camera, which is much better than we have in our own lab. It's an amazing camera with which you can film at 7,500 frames per second at HD format, so big TV. And what you can film with that is, for example, a fruit fly that takes off, and you can resolve the motion fluidly. It looks like a ballet. It's beautiful. So these participants, these 800 participants, can just choose the topic they like: an insect, a bat, a bird. It doesn't matter to us, and film this insect or animal and see how wonderful it moves. And because of that, we also learn something ourselves, because we don't have such movies of animals flying freely outdoors. So that's one.
Can you show us something?
Yes, so just to show you a little bit more about the research and also about the participants, we have another small clip from the program Labyrinth.
Wageningse wetenschappers willen het liefst alles wat in de natuur vliegt, vertraagd zien bewegen. Zelfs amateurs worden ingezet. En dat levert, hopen zij, nieuwe wetenschap en prachtige beelden op.
Maar wat heeft men dan voor elkaar gekregen? Die vleugel die is helemaal zacht. En daardoor dempt hij al het geluid, de achtergrond is dat. En daardoor kan hij geruisloos zijn prooi dus vangen. Maar tegelijkertijd heb je de vleugel van Havik en die is dus hartstikke hard en hartstikke stijf. En dat komt omdat als er heel hard gedoken moet worden of een snelle manoeuvre moet worden gemaakt, dan moeten die vleugels heel erg sterk zijn. Dus dat is een heel andere manier van vliegen en een hele andere oplossing. En dat vind ik dus echt geweldig, om die verschillen zo in één keer in je hand zo te kunnen zien.